Now let's talk about dimension analysis. Now at this junction, we just need the dimension of three things. The length. We know the unit of length as meter. There's a difference between units of length and dimension of length. The unit of length is meter. Now, what's the dimension of length? The dimension of length is L, capital letter L. Now, we also need mass. We know the unit of mass as kilogram. Now, what's the dimension of mass? That's capital letter M. Then time. We know the unit of time as seconds. What's the dimension of time? That would be capital letter T. Now, these are the three things that we need at this junction. So, and these are things that we are going to use for our dimension. Now, for example, look at this question. Let's say, for example, you are told to find the dimension of velocity. Now, how do we find the dimension of velocity? Now, when we are talking of velocity, what's velocity? Velocity is displacement over time, right? If the velocity is displacement over time, and we know displacement is the same thing as length. Distance also is length. So it means the dimension of displacement is L, and the dimension of time is T. So it means the dimension of velocity is what? Is L over T. Over T means T raised to the power minus 1. So this is the dimension of velocity. Now, 2. Let's look at let's look at force. What's the dimension of force? What's the formula for force to start with? Force is mass times acceleration, right? Now, our mass is in kilogram. That's the unit of mass. And what's the unit of acceleration? The unit of acceleration is meters per second square. Why is it meters per second square? Acceleration is mass, meter is length. So acceleration is velocity over length, velocity over time. And velocity over time, velocity is displacement over time. So it means acceleration is displacement over time. So from there, that's how we get our meters per second square. Now, what is now the dimension of force? Kilogram, that's for mass, that's capital letter M. And meter, that's length, L. Then S is second, that's T square. So this is M, L, T raised to the power minus 2. That's the dimension of force. Now let's look at another question. Let's say, for example, power. What's the dimension of power? We already know the formula for power. What's the formula for power? Power is force times distance over time. And now, what is force? Force is mass times acceleration, right? And our mass, so that's mass times what's acceleration? Velocity over time. So we can write this as mass times, and what's velocity? Displacement over time, and you then divided by what? Time here. So this is mass times displacement over time divided by time. That will be times 1 over time, and that is mass times displacement over time square. And our mass, the dimension of mass is M, displacement is L, and time over T square, that will be T raised to the power minus 2. So this is the dimension of force. Now distance, we already know the dimension of distance as L, and we know the dimension of time as T. So now, how do we now join all this together? So the dimension of power now will be, we know that of force. This is the dimension of force already as M, L, T raised to the power minus 2. That's force times, then distance, L, over what? Over time. And so power, the dimension of power is M, L times L, L square. Then T square, T raised to the power minus 2, divided by T. Divided by T means times 1 over T. And so this is M, L square, T raised to the power minus 2, times what's 1 over T? That's T raised to the power minus 1. And so the dimension of power will be M, L square minus 2 plus minus 1, that's minus 3. So T raised to the power minus 3. That is the dimension of power. So quickly, before we end this part, there is one thing we need to quickly talk about. And what's that thing? Let's quickly talk about mass and weights. Now, what's the difference between mass and weight? And that's the end for this part. Now, when we say mass, what do we mean? Mass is the quantity of matter contained in the body. Quantity of matter in a body. That's the definition of mass. And mass is a scalar quantity. We are still going to talk about scalar and vector quantity very soon. Now, what is weight? Force acting downward on a body, that's weight. Force acting downward on a body. And what weight is a vector quantity. Weight is a vector quantity. Now, we want to look at the differences between mass and weight. Now, what are the differences between mass and weight? If this is mass and this is weight. Now, the first difference between mass and weight is that mass is a scalar, very good, and weight is what? Weight is a vector quantity. Weight is a vector quantity. Another difference is that the unit of mass is kilogram, while the unit of weight is what? Is Newton. Now, the third difference between the two is that mass works by the principle of moments, by the principle of movement. We are still going to talk about the principle of movement. Why weight? Weight is governed by Hooke's law. We'll still talk about Hooke's law also. And the last but not least is that mass is constant. Mass is constant. And what? Weight varies. When we say weight varies, it means weight changes while mass is always constant. So with this, we have come to the end of this first chapter on quantities and measurements.